Alright, so our last video is going to be verifying an identity. So I know this looks really intimidating, but let's go back to what we know about verifying identities. First of all, we want to try to use the more complicated side and turn it into the other side. So here we've got a fraction, and it looks like we've got something that could potentially use a difference formula for cosine. A dead giveaway is going to be whenever you have a set of parentheses with two different angle measures inside of it, like this. That's going to be a giveaway that you probably want to work with that side and expand it using a formula. So this is a difference and it's cosine, so I'm going to go over here and I'm going to use this formula. So I'm going to write it like this: cosine of alpha minus beta over sine of alpha times sine of beta equals, and I'm going to change that top. I'm going to change it to cosine of alpha cosine of beta plus sine of alpha sine of beta all over sine of alpha times sine of beta. So we've made an even bigger mess. But here's the thing. Now we've got two terms over one denominator. What that means is we can break this fraction apart. We can think of it like this is a fraction and this is a fraction. And we can even kind of do it in our mind and see, oh, we have cosine over sine, and then sine over sine, sine over sine. So something interesting is going to happen here. So let's break it apart into two separate fractions. Cosine of alpha, cosine of beta over sine of alpha, sine of beta plus, and then our second numerator, sine of alpha, sine of beta over sine of alpha, sine of beta. Remember, what we're trying to go for is cotangent of alpha times cotangent of beta plus 1. So if we look over here, we've got that 1. We've got sine of alpha canceling and sine of beta canceling. It is important that they have the same angle in order for them to cancel. So like sine of alpha and sine of beta, they don't cancel because they're sine of two different angles. Now over here, and this is going to turn into a 1. Don't forget that. It doesn't turn into 0. It turns into 1. And over here, we have cosine of alpha over cosine of beta. So we can turn that into cotangent of alpha, cotangent of beta. Now you'll notice I am no longer just doing one step in each of my equal signs. Okay, so up here you'll notice I use the sum and difference formula. I actually use the difference formula. Right here I broke apart, and right here I canceled and I used the quotient. So now on anything skill 24 and up, you can do more than one reason within a step. And we're done. Now I know I promised you just one verifying problem. I'm not going to verify another, but I am going to give you one more example to have in your notes. My students last year had trouble with this, and I had forgotten about it till just now. But say I give you something like sine of 40 degrees times cosine of 20 degrees plus cosine of 40 degrees times sine of 20 degrees. And they want you to find the exact value. Well, it might look really, really difficult because we don't know how to find sine of 40 or cosine of 20 or any of these. But if you look over at your identities, this fits one of these patterns. It's definitely not the tangents. But we had a sum over here, and it had a sine times a cosine plus a cosine times a sine. And if we look here, sine times a cosine plus cosine times a sine. That's right here. That's this one. So we can actually go in the reverse direction of what we were going earlier. Earlier we were breaking things apart. Now we're going to be going and combining alpha and beta. So if we go over here, this whole thing is equal to sine of our alpha, which is 40, plus our beta, which is 20, which is sine of 60. And sine of 60, well, you should know that from your special triangle, is going to be 1/2. No, square root of 3 over 2. I lied. And that's it. So I just wanted you guys to have an example of that so you're prepared if you see something like it. Your practice problem, I almost forgot. Your practice problem I want you to do in your warm-up is this. And we'll do lots of practice tomorrow in class. But the warm-up problem is I want you to I want you to find cosine of, I gotta make one up because there's no good ones in here. How about pi over 12? Sorry for the delay. So there you go. I want you to find the exact value of cosine of pi over 12.